So if we have two vectors, so we have vector f1 and we have vector f2, all right, and we have them defined in their Cartesian form. So we know the x component of f1, we know the y component of f1, and we know the z component of f1, and we know this, and we can say we know the x, y, and z components of vector f2. All right, it's really easy to find the sum or the resultant vector of these two forces. All we need to do in that case is we're going to take the sum of all of our forces in the x direction, and we're going to add that up. So in this case, it would be the force 1, but force 1x plus force 2x times the unit vector I. And then for the sum of all of our forces in the y direction, we would have force 2 of x plus force 1 of y times, or plus force 2 of y times the unit vector j. And then we would sum all our forces in the z direction. So we would have force 1 z component plus force 2 z component. We would add them together and multiply by the unit vector k. And that would give us our Cartesian vector r. Okay? Once we have our Cartesian vector r, we could solve for the magnitude of vector r using the square root of the sum of the squares formula, and we could solve for the directions of r using that same magnitude and the coordinate direction angle. So we could divide the x component by the vector r, the magnitude of vector r, and take the directional cosines of each of those terms to determine alpha, beta, and gamma. Okay. All right. So we're going to do a few example problems to kind of show how you can use the definitions of our vectors, of a 3D vector, in order to solve for our coordinate direction angles, and also finding our resultant vector using these techniques that we developed in the last couple of videos.